ChipChip, you were supposed to get a white lab coat, not a robe.
KoonKoon, this is a science robe. Don't you know anything with science in front of it means smart?
But,
And did you not see? Glasses!
but,
And hello, beakers. Need I say more?
okay. But wait until you find out about clean rooms. This robe Mommy sewed you is cute, but look at all this fluff.
Okay, Mommy, let's get this lesson started.
Hello, and welcome to our Intro to Energy lesson. Energy is the capacity to do work or cause change. Well, what exactly is work? Work is an activity involving a force and a movement in the direction of that force. A common misconception students have is that work is done if there is no displacement, or more simply, movement. Work cannot take place if there is not a movement in the direction of the force. Energy is the currency of work. The formula we use to calculate work is work equals force times a change in distance, or delta x. Work is measured in units known as joules or calories. These are the same calories associated with food and nutrition that we've all heard of. If we feel guilty about eating a chocolate bar, we might exercise by doing work to burn off the 280 calorie deficit created by the chocolate bar. If we did this work by pushing a box, for example, say with a force of 500 newtons, we have half of our equation. But what remains is how far of a distance we need to push this box. Now, when we're dealing with the human body, this formula involves a lot of conversions and gets very complicated.
8 hours later.
In order to burn off 280 calories of energy, we would multiply that by 4,180 joules per calorie, which gives us 1.17 megajoules. Now that we've covered work, we can examine its currency, energy. There are two types of energy, kinetic and potential. Kinetic energy is associated with the motion of an object, and potential energy is associated with the position or composition of an object. I initially found the difference between these two types of energy difficult to conceptualize. So I'm going to get some assistance from my classroom helpers, KoonKoon and ChipChip. Here we have two great warriors. As they sit here unmoving, they are full of potential energy. It's easy to remember this by thinking of the potential of what they might do. Now here, as they start their epic battle, their potential energy becomes kinetic energy. This happens as they begin to move.
Mommy, we didn't sign up to fight lions. Run!
Now let's take a closer look at this transfer of energy. As ChipChip sits here, he's again full of potential energy, which is a stuffed animal's natural state. As he begins to fall, his energy shifts from potential to kinetic, and by the time he hits the ground, the energy has fully shifted into kinetic energy. Another misconception students have is that energy can be recycled. Energy cannot be created, destroyed, nor recycled. It can be converted to different forms or transferred, but the total amount of energy remains constant. This is known as the law of conservation of energy. Now, there are many subtypes of energy within kinetic and potential energy. Kinetic energy itself has two subtypes, one based off of movement and one based off of energy. A few examples of kinetic energy based off of movement are translational kinetic energy. You can think about this like the firing of a gun. There's also vibrational kinetic energy, which is simply vibration, like what your cell phone does when it rings or you get a notification. There's also rotational kinetic energy, which you can picture as the rotation of the Earth. Some of the kinetic energy types based off of energy are sound, electrical energy, and thermal energy. Within thermal kinetic energy, you also have radiant energy. Thermal energy is heat or fire, and radiant energy is the light that allows us to see the flame. Within potential energy, we have several different types. We have chemical potential energy, gravitational potential energy, elastic potential energy, like when a spring is a state of compression before it's released. There's also electrical potential energy, such as within batteries, and nuclear potential energy, such as with an atomic bomb. Intermolecular potential energy, which involves the attracting and repelling of atoms, is another type of potential energy. This concludes our lesson on the introduction of energy. To recap, we learn about work and how we calculate it. We learn about potential and kinetic energy, along with the various subtypes. We cleared up a few misconceptions about work and conservation of energy. And there is more to the subject of energy than these basics that we covered today, and as always, we encourage you to explore all topics further. Thank you for watching.